So we're doing inverses today. And you maybe did a little bit of inverses last year, maybe a little bit. Let's start by just graphing. The equation f of x equals x plus 4. And then on the same graph, we're going to graph g of x equals x minus 4. There's another way of writing the inverse besides g of x, and it looks like this. F to the negative 1 of x, it's f inverse. I'd say that. So I'm going to graph those on the same graph, and I color-coded them so you can see which one's which. We begin at 4, and we use our slope up 1 over 1. Use our straight edge. Second equation, begin at negative 4 up 1 over 1. And then one more thing we're going to do to that graph is we are going to graph the line y equals x, and that I'm going to dash. Graph the line y equals x, and I put it in dashed. Then I'm just going to pick some points from the blue line, from the x plus 4 line. I'm just going to pick just a bunch of points that I had graphed. There's infinitely many on it. I'm just going to pick some of them. 0, 4, 1, 5, 2, 6, 3, 7. Then I'm going to pick a bunch of random ones on the red line also. On the red line there is 4, 0, 5, 1, 6, 2, 7, 3. Now there are infinitely many ordered pairs on these lines, but I picked ones with a purpose. What do you notice about all the ordered pairs that I picked? Yeah, I mean, I know what you mean, but like the x and the y are changed. They're switched. They're interchanged with each other, right? If we have two functions that are inverses, this will always be true. You can take one ordered pair from the first function, and it will be x and y switched on the other function. So one random point here on the blue one, if I were to choose -1, +3. Then what should be on the red one? 3, -1. So I just switched the x and the y, and you can see it is on there. Something else about the graphs themselves, and the reason why we drew that y equals x line, is that these graphs are a reflection in the y equals x line of each other. So how we were doing reflections in the x-axis, we were doing reflections in the y-axis, now we have a reflection in the y equals x line. And that only happens when we have inverses. This is two inverses, and they've already told you what they are, and we're explaining how inverses work with opposite operations, how they undo each other. So I'm going to put in a point. I'm going to say f of x equals 2x plus 3. Let's find f of 4. If I were to find f of 4, I would first take 2 times 4, and then I would add 3. So that's what is written underneath. First, multiply by 2, then add 3. That's what I would do if I put 4 in. But if I put 4 into g, if I did g of 4, I would first subtract 3, then divide by 2. So you see how these operations are completely opposite operations. What's the opposite of multiply? Divide. What's the opposite of add? Subtract. They're opposite operations and they're in the opposite order. So they're like completely undo each other. That's what inverses do. And then because with inverses, because if in the first one we have x, y, and then in the second one we have y, x, like we just switch the x and the y, it works for domain and range because x is the domain, y is the range. So if I know the domain of the first one, then I found the range of the second one. I can just switch those. And then here's a picture and a table of the same equation that I was just talking about. You can see how it is a reflection in the y equals x line. So we're going to graph. I want you to go ahead and start by drawing that y equals x line. Go ahead and get that on your paper. Y equals x line. And you're going to do that in your homework. You're going to first graph y equals x line. The y equals x line. And it says to first find the inverse and then graph it. And really, you can do it in either order. But that's the order I'll teach it in, but you really can do it in either order. So we're going to algebraically find the inverse. Here's your steps. First thing we're going to do is f of x. It's the same thing as what? Y. So the first thing I'm going to do is I'm going to make it y. Make it y equals 3x minus 1. So you just change f of x into y. And then what we're going to do is we're going to find the inverse. And to find the inverse, we're going to switch x and y. That's how you find the inverse. So now I have x equals 3y minus 1. Boom, that's the inverse. Or not that. So that is the inverse, but we're going to take it a little bit further because we're graphing this. We're going to solve for y. So I'm going to add 1, and then divide by 3. And I get, what? Question? So I get y equals 1/3 x plus 1/3. And then there's one more step. This is a function, so we're going to write it back in function notation. And function notation would mean that we have the g of x in front instead of the y. So that would be our inverse function. And we're going to graph both of them. So we got 1/3 x plus 1/3. I got to scroll up, sorry. So to graph the 3x minus 1, we first think like that's a line. So I need my slope and my y-intercept. My y-intercept is where I begin. So that's 0, -1. And then from there, we're going to use our slope, which is 3. 3/1. And then we have to graph our other function. Well, what's not pleasant? It's about trying to graph our inverse function. What's not pleasant? We have a y-intercept at a fraction. It's not very fun. So you do have other options on how to graph the inverse. What did we learn about the ordered pairs of the inverse? How do we get the ordered pairs? You just switch the x and the y. So if I use some ordered pairs from the blue one and I just switch x and y, I don't have to worry about this. So an ordered pair, I know for sure it's my y-intercept, 0, -1. So now I'm going to graph what ordered pair? -1, 0. And then I can look carefully, 1, 2. So I'm going to graph 2, 1. What is the slope of the new one? Of 1, so I can just use the slope now. I don't have to think about all the rest of them. I can just use the slope. I mean, I can find the other ordered pairs and switch them all. Either is fine. And it should look like it crosses the y-axis at 1/3, but I didn't have to do it myself. Right? In today's homework, you're going to be given an equation, and you're going to find the inverse algebraically, and then you're going to graph the equation and its inverse. So that's all you're doing for today's homework. So I'm just going to show you a couple more examples with non-linear ones. So non-linear, they're going to reflect over in the y = x line, just like the lines did. But they might look a little different. Here we've got a quadratic, and we reflect it, and it looks like this. This one's hard to see on your paper because it's not in color. But if you look up here, the blue one is the original, and then the red one is the inverse. Okay, it's reflected over that y = x line. When we talk about functions, we're talking about stuff that passes the vertical line test. Okay, so when we talk about this blue one being a function, you see it has f of x = x². You can only write it f of x if it's a function. And I take my vertical line and I go left to right, and how many times does the blue one pass through this vertical line at any point? Huh? How many times does it pass through? Just once. Every single time, just once, right? The red one, you see they did not write it as f of x or g of x. You see they didn't? It's because it's not a function. So how many times does this one pass through? 2. It just means it's not a function. We can still find the inverse. We just can't write it as g of x. We'd write it as y = instead. That's the only difference. They didn't write it as y =. They didn't take it as far as we're going to do in our homework. So we're going to do that for this one. Here it says f of x = x². That's y = x². Here it says x = y². Let's take x = y² and actually solve it. So it says y =. So how would I solve x = y²? So it says y =. What would we need to do? What's the opposite operation of squared? Square root, you can just square root. But you should have learned something in the past couple of years that when you square root, there's something else you got to do. Plus or minus. So we have y = plus or minus square root x, which that's the inverse. It's not a function, so I'm not going to write g of x. It's just y = instead. Do we know what the square root of x looks like? What does it look like? So this is the square root of positive and negative. I might said it wrong. It's positive square root of x and negative square root of x. So we've got our positive square root of x, and then what makes the negative square root of x? What does the negative outside it do? Reflect in the x-axis. So that is the bottom part. So there's our positive up here, and there's our negative up there. And that's how it looks like a parabola to the side, because it's a square root and a square root that's reflected, put together. Okay, example 2, finding the inverse of a quadratic function. There is a typo on your paper. There's a typo on your paper. I've already fixed it up here. It's this -4 right here. It says 0 on yours. Let's just say -4. Apologize, but I wasn't going to reprint all of those for one number. Care about the inverse. We're going to find the inverse of f of x equals x plus 4 squared. For this one, I'm going to choose to graph it first. So let's start with our y equals x line. Go ahead and jot that down. Y equals x.